Hi scholars, today we're going to spend some time talking about rational expressions, how to simplify them, as well as how to solve rational equations. So first off, what does this word mean? Well, a rational expression is nothing more than an expression, something of the form a over b, where a and b are polynomials. So for example, 3x over x squared minus 2. This is an example of a rational expression, right? Now you'll notice that the formulation of some number over another number is just like a fraction, right? And so our big idea, our first big idea, and the thing that's sort of this entire video is about, is the fact that we use these same rules for rational expressions that we use for fractions. So everything that you remember about how fractions work, that same thing is going to be true for rational expressions. So let's take a look at examples, and we're going to do them side by side, okay? So for example, simplifying. Okay, here's a fraction, 6 over 15. Back in middle school, they said simplify this fraction. You would say 6 over 15. Well, I actually have a common factor of 3, so this is actually 2 over 5, right? And what you did in your mind, maybe not explicitly, is you said that 6 is 2 times 3, and you said that 15 is really 5 times 3, and then you said, wait a minute, they have a common factor of 3 in the numerator and denominator, so I can cancel those out, right? And what am I left with? Well, I'm left with 2/5, and there it is, okay? Well, here's an irrational expression. How could we simplify this thing, okay? If I want to simplify this thing, what does it turn into? Just like here, you factored out numbers. Here, we're going to factor out expressions. So let's just look at the numerator. The numerator is 2x minus 8. How can I factor that? Well, I notice that each of these two terms, it's a binomial, each term has a factor of 2, so I can pull that out. I can actually rewrite the numerator as 2 times x minus 4. This is my new numerator, okay? What about the denominator? I still have two terms. Here they have a common factor of x, so I'm going to factor that out. This is x times x minus 4. You can verify, right, by multiplying back out, and you'll get to this original equation. And now I look at this and I say, wait a minute. Instead of having a common factor of 3, I have a common factor of x minus 4. That's okay. That's allowed. I can actually cancel x minus 4 and rewrite this entire expression as 2 over x. So this is simplifying in the same way that we simplified here as 2 over 5. Now there's one thing that we want to make sure we consider with rational expressions is you want to make sure that the denominator does not equal 0, right? So remember when we were dealing with fractions, we said, well, let's say, what's the value of 3 over 0? And we said, no, this is undefined, right? We would call this undefined. And so the same sort of pattern, we can't never divide by 0. And so the same thing is going to happen when we're dealing with rational expressions, right? We want the same principle to hold. So in this case, we want to look at our denominator, and we want to say that any x value that would make this thing equal to 0 cannot be allowed. We say it's not in the domain of this expression, right? It would cause this expression to be undefined. So easily, right, since we've already factored our denominator here is x times x minus 4, we want to make sure that we consider when is this thing undefined. Well, it's undefined when the denominator is equal to 0. Well, when is this true? This is true when x equals 0 or x equals 4, right? If I plug in 4, I would get 0. If I plug in 0, I would get 0, okay? And so this is, we always need to make sure that we check when is this thing undefined. Before we move on, I want to call your attention to a very common mistake that students make. So let's say, for example, I have something that looks like 3x plus 6, that's fine, over whatever, x squared plus 6, right? We say, okay, can we simplify this? How can we break this up? So it's really common for students to say, oh, look, there's a 6 in the top and the bottom, right? It's the same number in the top and the bottom. I know what I can do. I can just cancel that, right? So let me just cancel that and then rewrite it as, well, what's left over is 3x over x squared, which, right, you could actually keep going and say this is just equal to 3 over x. Okay. So this is wrong. This is incorrect. You can't just cancel a part of an expression, right? This, right, it's very important to remember, this 3x plus 6 this is one expression, right? X squared plus, this is one thing, okay? And I can't just say, oh, let me just cancel a part of it, right? I mean, if I said, okay, I can just cancel parts of fractions, right? Let's see what that would mean. Let's say the number, let's take the number 2/3, right? I know 2/3, it's a fraction, right? If I have a circle, I divide it up into 3, I shade 2, right? Here's my 2/3, okay. Well, let's use the same logic. Well, 2/3, I know that 2 is equal to 1 plus 1. I know that 3 is equal to 2 plus 1, right? Now, if I'm using my same logic, I would say, look, they have a common 1. Let me just cancel that out. And then it turns out that 2/3 is actually equal to what's left over, which is 1/2, which of course is this, right? Are these two things the same? No way, no how, never are these two things the same, okay? So really keep an eye out. You can cancel, if you could cancel the 6's if they were factors, right? So if it was something like 6 times 3x over 6 times x squared, yeah, cancel the 6's all you want. This is okay, right? But if it's plus 6, it's a part of this whole 3x plus 6 expression, okay? And so you can't cancel just any old parts that you want. Great. Let's take a look at a couple more examples. We'll try to move through them a little quickly now. So adding and subtracting, we remember when we were dealing with fractions that I can't say that 1/2 minus 1/3. I can't just go 1 minus 1 and 2 minus 3, right? I can't subtract tops or numerators and denominators like that, right? What I need to do is I need to find a common denominator. So in this case, the common denominator would be 6. So what I have to do is I have to take 1/2. So I'd have to take 1/2 and multiply it by 3 over 3. I'd have to take 1/3, multiply it by 2 over 2, and that allows me, right, to rewrite 1/2 as 3/6 minus 2/6, and now I can do it because I have my common denominator of 6, and now I can subtract numerators, so 3 minus 2, so everything would actually equal to 1/6, right? So this is how we would do it if we were just dealing with fractions. Well, we can do the same thing when we're dealing with rational expressions. So here I have a denominator of x plus 1 and a denominator of x squared. These are different, okay? I want to have a common denominator. Well, in this case, the common denominator is just going to be the product of these two denominators. So I'll just rewrite it. The common denominator at the end is going to be x squared times x plus 1. So in order to get that denominator here, right, we would multiply the top and the bottom by x squared times x squared. We end up with a 4x squared over x squared times x plus 1, right? Notice I just multiplied by x squared over x squared. Again, I can do that same way I could multiply by 2 over 2 or 3 over 3 because this is just equal to 1. Nothing is changing. We're just rewriting the same thing in a slightly different way, right? That'll allow us to make use of this property that we can only add and subtract when we have the same denominators. So let's do the same thing here. So here I have 2 over x squared. So I already have my x squared term, right? Here's my 2. But I need a little more, right? I actually need to have a factor of x plus 1 in here. So we're going to multiply the top and the bottom here by by x plus 1 over x plus 1. And I end up with 2 times x plus 1 over x squared times x plus 1, right? And now that I have the same, right, denominators, this is now the same as this, now I can deal with the numerators and I can actually subtract them. So I can actually write on the top that this is going to be equivalent to 4x squared minus 2 times x plus 1, which is really just minus 2x minus 2 when we distribute, okay? And so this right here is our final answer. And we want to make sure of one thing. We want to ask, when is this expression undefined, right? This is still very important when we're dealing with rational expressions. It's undefined when either of the denominators are equal to 0. So when x plus 1 is equal to 0, so we say it's undefined when, that would mean that x is equal to -1, right? Because if I plug in -1 here, -1 plus 1 is 0. Or when is x squared equal to 0? That's just when x is equal to 0. So these two values are not allowed, right? We cannot substitute these two values in this expression and have it make sense. Okay, let's take a look at one more example. how do we solve rational expression or rational equations, right? So now the only difference here is we have an equal sign. Well, when we were dealing with fractions, you would cross multiply, sure thing, right? Cross cross, you get that 5x is equal to 6, so x is going to be 6 over 5. Okay, same idea here. Here, you notice you may have variables in the denominator. You may have a couple expressions in the denominators, could be in the numerators. It's the same idea. Let's just cross multiply, right? And we end up with, let's do this one, x times 3 is 3x is equal to 2 times x minus 5, so 2 times x minus 5. And we want to be a little careful here because it's 2 times the quantity of x minus 5, right? So we want to make sure that we keep our parentheses here. It's very important. And now you just have a two-step equation, right? We can just solve it as we would usually. 3x equals to 2x minus 10. We end up getting that x equals negative 10. And we can actually just check that real quick. If I plug in negative 10 in here, I get 2 over negative 10, right? Which is the same thing as negative 1/5. And if I plug in negative 10 right here, I get 3 over negative 15. Which is the same as negative 1/5. And so this checks out. This value of x does solve the equation. And once again, we want to double check, when is this expression undefined? Well, it is undefined when either of these denominators are equal to 0. So this is either when x equals 0 or when x minus 5 equals 0, which is when x equals to 5. And so these are the two values that result in this expression being undefined. Now, to close off, let's just do a quick bonus one, right? Look at this equation. Looks like we can set it up, proportions, let's cross multiply, so forth and so on, right? Before we do that, let's try to factor the left side of this equation. Now, 2x plus 6 is nothing more than 2 times x plus 3 over x plus 3. Okay. And oh, it's the same thing, right? I can have the same factor, x plus 3, so I can cancel them. And look at the equation I'm left with. 2 equals to 1/2. Is this ever true? This is never true. Okay, so this equation has no solution. And you say, wait a minute. What are you talking about as no solution? I can cross multiply, it'd be very easy, right? I could do 2 times 2x plus 6 equals x plus 3. That's an equation, I can solve it. You're right, you can solve it. And you're gonna end up getting x equals negative 3 as an answer. Can x equal negative 3? No. When x equals negative 3, this is equal to 0. You get, as a solution, the one value of x that would result in this rational expression being undefined, right? So being able to, take-home message here is that being able to factor, to find common factors and cancel them out, sometimes can save a couple of steps where you could do a lot of math here to just find an answer that is not allowed, right? Awesome.